Everybody, I'm Ricky Robinson from NICTA's Queensland Research Lab. I work in the Broadband and Digital Economy business team of NICTA. Well, which clicker is it? This one? Yes? No. Broken.
So that one? You good? You good?
I'm good now. Okay. Thank you. I'll skip over this because Hugh's covered this already. I like to pitch NICTA as saying NICTA works on problems that are obviously hard, right? They're the kinds of problems that you explain what you're doing to someone, they go, "You're doing what?" I'd like to see you crack that nut. I'm not going to hold my breath, right? We also tend to come up with solutions that are not always obvious, at least not to the casual observer, right? Not to the average person on the street. And it's funny how often now public sector information is becoming a part of the solutions that we deliver. My example of obviously hard problem, okay, is how do you create a map of Australia to a depth of 5 kilometres without digging up any dirt, without drilling any holes, so that you can locate geothermal energy wells and characterise their economic value, right? Obviously, that's a hard problem. I'm guessing that not many of you thinking, I'm going to apply non-parametric Bayesian techniques to swathes of public sector information to do this, right? A normal person doesn't think that. But people like you who wrote the book on non-parametric fusion techniques, they do think like this, right? And increasingly, NICTA, with our industry partners and with our government partners who often provide us the data, we're applying these techniques to a growing number of problems. Okay, so geothermal exploration is one of these. This is a tool that we've built for doing geothermal exploration and other solving other problems in that space. It's called Subspace. This tool it works a little bit like Google Earth, I guess, except it allows you to virtually dig holes, right? So you can fly over Australia, find a spot in the ground, cut away some of the dirt, and see what's under there. And you can characterize that. You can figure out is there granite down there with seams that I can pump water into and extract the heat, right? Another area which Hugh's talked about earlier is infrastructure, transport, and logistics. We're doing a lot of work in this area, and a lot of that work uses public sector information. Some of it open, some of it not. One, we're looking at archived traffic data in Sydney, and we're looking at how changes to the infrastructure have affected bottlenecks in the Sydney traffic system, right? So we can also do predictive models around that. So if we stick a new bridge here, put a new road there, or take this bridge away, how does that affect where the bottlenecks form? And on top of all that, we're layering social information. So this graphic here is using Twitter to figure out where incidents are happening in real time. This one is a tool that creates decision trees from traffic data. Basically, it says if this kind of incident occurs under these certain conditions, is my delay likely to be significant? Okay. Well, on predicting traffic patterns, the cool thing that we're doing here is that between pairs of green markers up there, that's unmonitored sections of road. Okay, so where the New South Wales government haven't put sensors in the road. So this is actually data from Optus originally that comes through the Traffic Management Centre. And we are figuring out on the unmonitored road segments whether incidents have occurred along there. And we can do that by generating a model about how long it should take to travel between those points, and then monitor that over time to see if traffic is taking longer to get through those checkpoints. This one's about identifying incident clusters in the data, and then learning rules about those clusters. So we can say if the first incident in this cluster was major, and it's affecting 4 lanes of traffic, then with very high probability, the second incident, the subsequent incidents in that cluster are also going to be major. Okay? This one's a little bit different. It's not in the infrastructure, transport, logistics domain. It's more in the digital economy domain. So we all love government regulations, right? Policies, rules, acts of parliament, whatnot. Our tool Rigorous takes regulations and policies that have been properly encoded using a formal method, along with your company's business rules. And then we also input event messages and event logs, so you can monitor in real time whether your company is operating within the bounds of government regulation, right? So it's kind of a red tape cutter, if you like. I was the first speaker in the digital economy stream, so I thought I'd better say a little bit about the digital economy, what I mean by that. So this is Nicholas Negroponte, the founder of MIT Media Lab. He's had a lot to say about the digital economy. Starting in the mid-90s, he wrote this book, Being Digital, and that's kind of where this concept of digital economy started being talked about a lot more. His general point was that the world is moving and more businesses are moving from atoms to bits. But at around this time, the internet was, the web was beginning to take off. And so a lot of what he said was interpreted in terms of, how can I use the internet to reach more customers? Or it was about where transactions between businesses and customers are happening, i.e. the web, right? But I think he was trying to make a deeper point about how technology and how digital is affecting businesses. This guy, might know him, Mark Andreessen, founder of Netscape, now a successful venture capitalist in the Valley. He, a couple of years ago, wrote a much talked about article called Why Software is Eating the World. And to me, this article really articulates what the digital economy is to me, and I think what Nicholas Negroponte was trying to get at as well. And that is that digital and software in particular is transforming the world, okay? So more and more businesses are software businesses. So for example, there's a mining company being started in Seattle, I think, Planetary Resources, right? The people who work for Planetary Resources are ex-NASA software engineers. And so this is a really great example of how software is transforming a mining company or the mining industry, okay? So are we really talking about digital economy? I think it's more, we're talking about the whole freaking economy, okay? And Andreessen's article really goes to the heart of that. Software companies are reinventing many, many industries. So my recipe for growing the economy in your city, the Gold Coast or elsewhere, teach your citizens to code and focus on the big challenges. Okay, if you're focusing on really big challenges and getting your startups in your accelerators, for example, to focus on really big problems, there's no way they can't put software at their heart if they want to be successful. So in order to develop that digital economy, focus on solving big problems, and the digital economy part will just happen, okay? If you don't believe me about the importance of why it's so important to teach our citizens and our kids especially to code, Don't take it from me. Listen to Mark. Learning to code is the single best thing anyone can do. Nicholas, programming allows you to learn and learn about learning and teaches you how to think. Mark Zuckerberg, Facebook hires engineers. That's their policy. That's their one single policy. We hire the best engineers we can get our hands on. Meg Whitman, if you have a daughter, she should be an engineer, by which she means a software engineer. Ariana Huffington in the news. Venture capitalist Ron Conway, code. Stephen Hawking, computer science, code. Astronaut Leyland Melvin, teach your kids computer science. The Creative Commons people, studying computer science is the best thing that you can do for your kids. Brad Feld, another angel venture capitalist guy, basically the father of the Boulder, Colorado startup community. A musician is telling us to code, right? President Bill Clinton, code, computer science. Richard Branson, who's here in Queensland this week, teach your kids to code now. And finally, I thought this was a good one to end on. Mike Bloomberg, Mayor of New York City. We encourage every student who can't decide whether to take that computer science class to give it a try. New York City's economic future depends on it, right? New York. Moving on to open data. I should say I was involved in the implementation and the rollout of Campbell Newman's Open Data Revolution up until this point. So putting out the initial portal and getting initial data sets up there, making sure the data sets can actually be used by developers and programmers, making sure the platform portal has an API that developers can use to easily get data. Why is it important? The other thing is my first post-university job was also working for a Brisbane small business which is completely built off open data, and we're going to revisit that one later. Why is open data important? In the EU alone, the direct and indirect value of open data or public sector data, because this is all public sector data, not just the open data, 140 billion euro annually, and this was in 2010. Examples of successful businesses that have been built off open data. So you might know this one, Zillow. It's kind of like realestate.com.au, right? Except these guys are awesome at analytics and machine learning. Okay, that's why they are leading this space. They've got access to tons of open data, and in their case, it is all open data. But these guys are using machine learning techniques, analytics, to provide value to customers. So they do really awesome estimates, for example, of what a property is going to sell for, and so on. These guys are a brand new startup. They're called Enigma.io. These guys are drawing together open data from all over the world, so they claim to have thousands and thousands of public sector data sets, and they're linking these things together, again, using machine learning, right? So they're learning about relationships between different data sets across the world. And these guys were just funded, seed funding, mind you, seed funding, not A series or anything like $1.1 million from some top-tier Silicon Valley venture capital. And we come back to, okay, so these guys are who I used to work for before I worked for NICTA. When I left university, I worked for a company called Global Roam. Don't ask me why they're called Global Roam. It has nothing to do with global roaming. What these guys do is they take open data, energy dispatch data from the national electricity market, and they build visualization and decision support tools for large energy users. So things like steel smelters, zinc smelters, companies like that. Because these large energy users, one of their core costs is electricity, okay, the power that they use. And they they often have exposure to the spot market. So you and I, we buy our energy from Ergon or whoever it is. These guys often buy directly out of the spot market, and that's a hugely volatile market. It can go from $20 up to $60 in like half an hour. Okay, and so what this tool does, it was called Decide. It allowed large energy users to decide whether or not to switch off their smelters. Okay, so do we curtail our usage of energy at this point? And simply by curtailing 10 to 20 hours per year, you could save millions of dollars for if you're a large energy user. So yeah, check that one out. They're growing. They're doing really well. These guys presented at the opening the vault event that Ray was talking about earlier. I think I'll skip this one. This is just an idealized pipeline, open data pipeline. I guess if you wanted to look at a few things, so I think the availability of real-time data is becoming much more important these days, and also novel data sources, all right? And again, analytics and machine learning, really important all along that pipeline. Cleaning data, building the actual applications, and so on. A point I wanted to drive home about the digital economy, really, and growing the economy locally. Open data is a global game. Okay, when you put data out there, it's available for anyone to use. So, it's available for anyone to use, not just local companies. And so, although by putting open data out there, you're allowing a Google to come and take that data and integrate it into their Google Transit application, for example, your citizens directly benefit because now they get to use this cool tool. But you're not necessarily stimulating growth of the local economy, right? It's very hard to compete doing a transport app with Google Transit. It's already there. They just need to stick the data in. And so the point I want to make is it's not about the data, right? It's about the whole 9 yards. It's about the innovation around that. You've got to make sure that you're not only releasing open data, but that there is an infrastructure support system to start startups developing cool tools, solving hard problems with that. And only by focusing on those hard, unique problems are you going to have something of value that's not already out there. Okay? And this comes back to the analytics and machine learning thing. So I liked this Capgemini consulting report, which was put out in February this year. And they're saying one of the overlooked benefits of making open data available to the public is that you then have a resource there on which to start teaching kids, other citizens, how to develop big data skills, right? You've got real world data, not toy data, and you can start using that data to teach kids in your university classes, at high schools, etc. This goes back to the point about open data is the starting point. I think Hugh made this point in his presentation too. Open data is just the starting point. It's all about what are the problems that you're solving, how do we solve them. The data custodians in government often know a heap about that data, so even if they release it, it pays to go and talk to them, right? And also to build up the networks around data. This brings me to the city as a platform. So a while back, this was a kind of a think bubble, I guess. Street Program Your City. It was a pilot project that we had going at NICTA about 5-6 years ago. And it was basically, if you wanted to think about building an API for your city, okay, and everything under that. So exposing all the data in the city, whether it's real-time data from sensors, whether it's data in open data repositories, whether it's open data, private, proprietary data, and having a platform there that would allow end users to access that data or to send their computation to the data if for some reason that data can't be downloaded. Okay, so these issues that we were talking about with proprietary data sets. So who is kind of doing this? And there's a lovely portside city in Spain called Santander. These guys are being visited by IBM, Microsoft, Cisco, a whole bunch of big companies that see themselves as the leaders in intelligent cities, smart cities, digital cities. These guys are doing something really great. They're cash-strapped, but they've got a very visionary mayor. And he's got some researchers actually to deploy tens of thousands of sensors in the city. They're instrumenting a whole bunch of things. They're opening up all their data repositories. They're providing a platform for their people and their companies and their businesses to extract data, to build creative things on top of that platform, and also to enable the social networks around all that. Okay? And the other thing that they're doing is it's not just data out. They're also building tools that will allow you to control elements of the city. Okay, so actuate things like controlling the level of street lighting is one particular example that's being done in Santander. So Santander, to me, is a great model for how something like this might work. And my final slide, I kind of wanted to put something up there that said, you know, this is not just, you know, little Ricky from NICTA talking about this stuff. This is Rachel Hout, the CDO of New York City. And she was asked in an interview, you know, what are the things that you would like to see in New York City, or any city for that matter? So digitally speaking, 3 things I'd like to see in my ideal city is connectivity, high-speed connectivity, government APIs and real-time sensors, so a platform, right? And teach your kids to code, okay? So if I had to leave you with a message today, it would be teach your kids to code, focus on solving big problems, and the digital economy will take care of itself. Thank you very much.